Well, it's nice to meet everyone. My name is Sanjay, and today I'm going to be talking about 3 ways to test your Python code that uses Amazon S3. Here's the agenda for today's talk. First, I'll try to convince you about why you should even spend time testing S3. Then I'm going to introduce a really simple create, read, update, delete app that's backed by S3. We're going to walk through the process of writing tests for this application using 3 different libraries. And at the end, we will compare and contrast them all and talk about which one is best for your use case. So why should you test S3? I think fundamentally, my opinion is that it's really, really important to test code that interacts with external systems. And I often see this getting skipped. I have a couple guesses as to why this happens. The first is that people are unfamiliar with how to test external systems and they find it intimidating. Another one I hear is that you're just testing the API, so these tests won't be valuable. And I actually don't believe that's the case. I think that you're testing a lot of business logic around how you use and call the API. And that goes into the third bullet point, which is that I believe that even very basic tests can help catch bugs with really critical business logic. So I want to introduce a very simple create, read, update, delete app. It's for cooking recipes, and it's backed by S3. It's only about 20 lines of code if you don't include doc strings. So there's a class called recipe. It has a recipe can have a name and instructions, both of which are strings. There's functionality to fetch an existing recipe by its name, which will go look in the S3 bucket and get the data. There's a method to update an existing recipe if you just want to update the instructions. You can delete a recipe. And finally, you can save a recipe, which actually persists the data to S3. So this is about as simple as it gets. I intentionally picked a really contrived example just to be able to walk through some very simple tests. So usually when I give this talk, the option 1 that I demonstrate is how to write tests using Moto core stubs. Since today I'm giving a lightning talk, only about 10 or 15 minutes, I'm going to gloss over this part, but I'm happy to post the code later. At a really high level, with Moto core stubs, you have to create what's called a stubber for the S3 client. And so you can do that using this PyTest fixture that I put here. Once you do that, you basically have to stub out exactly what the responses are that you expect to get back from the API. So, for example, if you're calling the put object API, you have to tell it like what response you expect to get back. And this was an example response that I stubbed out. I'm going to gloss over the remaining coding examples for this to be able to focus on the last two libraries. But at a high level, I find that Moto core stubs are functional, but they're not easy to work with. I find that creating stubs is very, very time consuming because, and to make them even look somewhat realistic, you end up mocking a bunch of fields that your code doesn't really care about. And it almost took me more time to write the stubs than to write the rest of the tests. So when I was looking for a better solution, I found a library called Moto. Moto is a pure Python library that makes it really easy to mock out AWS services in tests. What I'm showing you right here is a PyTest fixture, and we call this mock S3, which is used as a context manager. It's a function from Moto. And when we're inside this context manager, any actions that we perform that would normally go to S3 are instead going to go to Moto's virtual AWS account. So I make this PyTest fixture. We make an S3 client that's going to be pointing at the Moto virtual account. And because that account is completely empty, we also have to create whatever bucket we're going to be dealing with. Once we have this set up, it's super easy to start writing tests and just pretend that you're almost interacting with the real version of S3. So here's a test for the create and get logic. What we're doing here is we're making a recipe for nachos, and we're saving it, which is going to persist data to the Moto fake S3 bucket. Then I try to fetch it by name, and I'm able to successfully do that, and I see that the name and instructions of the recipe are what I expect them to be. I also wanted to make sure this wasn't a fluke. So the next test makes sure that we raise an exception if we try to fetch a recipe that doesn't exist. So I'm trying to fetch a recipe called sandwich, which of course doesn't exist in my bucket. And we get the no such key exception back from S3 in that case. I also wrote a test for the update logic. So what I'm doing here is I make a recipe with some old instructions, and then I want to update them and make sure that that data got persisted to S3. So first I make it with the old instructions, and I save it on this line. Next I call update, and I update it. I create a Python object that has the updated instructions. But note that I haven't called save yet. And the semantics that I decided on arbitrarily in this application are that if I don't call save, then nothing gets persisted to S3. So when I try to fetch the recipe again, I still get the old instructions back. But then when I call save on this Python object I just made, and I fetch the recipe one more time, this time I get the new instructions. So as you can see, these tests are very simple and very easy to write. Finally, the last one I want to show is for the delete logic. So here I'm making a recipe for nachos. I'm saving it, which persists it to S3. I call the list objects API, and I make sure that we see one file in this S3 bucket, and that the name of that key is nachos. Then I call delete, and I see that actually there's no data left in this bucket anymore. So we can see that that worked correctly. Overall, I think Moto does a fantastic job of implementing the S3 API. It's super easy to install. You just pip install it. It feels like the real S3, and it doesn't require any code changes. The third option I want to show you is a library called LocalStack. LocalStack allows you to bring up an entire fake AWS cloud stack locally. LocalStack is not pure Python like Moto, so you have to bring up a server so that you can communicate with it. For me, the easiest way to do this was with Docker Compose. For the sake of time, I won't go over this YAML file. With LocalStack, again, we have to mock out the S3 client, but it works a little bit differently this time. This time, we use the boto3.client, but we actually pass the endpoint URL, and we point it to where the LocalStack server is. What this does is that any actions we do that use boto3 and try to communicate with S3 will now communicate with the LocalStack version that we have running. And actually, with this fixture in place, we can run the exact same tests that we used for Moto. So I repeated them below for completeness, and they all run. But they're the exact same, and the only difference is that I swapped out the fixture to use the LocalStack fixture. I think generally this is really powerful when you can basically have two separate drop-in replacements for the S3 API. And I didn't have to change any of my code or any of my tests. I felt like they were both doing a very good job. So I wanted to talk briefly about lessons learned for testing external systems and how to get over that hesitation there. When testing external dependencies, I think it's really important to look for mocks that feel realistic. And Moto and LocalStack both meet that bar. They both implement the API, at least all the parts of it that I've used. They feel real, and they required no code changes for me to get started. I also wanted to point out that you might be feeling like this was very academic. I showed you some 20-line application for recipes, but how would this work in real life? This has actually helped me catch a bunch of bugs in my own code. One time I misunderstood how S3 versions were computed. I thought it was purely based on content, and very basic tests saved me from pushing a bug to production. Another time, similarly, I've had trouble, I guess, reading the docs for S3 versioning. I wasn't doing a correct job of deleting versioned objects, and some tests helped me catch that. And finally, at work, I manage some ETL processes. And I want to make sure that in production, we're moving files around to the right place and we're processing all of them. And so I write tests to give me peace of mind for that. So just to summarize, you might be leaving this talk thinking, okay, should I use Moto or LocalStack? And I think, both are really great, but I'll talk about them for just a minute. So both of these libraries can be used in server mode to test code in multiple languages. So even Moto can be run as a server, just like we ran LocalStack. They also both implement mocks for many other AWS services, not just S3. So you really get a lot when you invest in one of these tools. One of the differences is that Moto is pure Python. So if you have a Python test suite, it doesn't require any extra build step, just a pip install. On the other hand, LocalStack requires another build step, but its architecture is probably slightly more realistic. In my opinion, you really can't go wrong with either solution. For me, if I'm using a Python project, I use Moto just for ease. But if I'm programming in another language and I have to start up Moto as a server anyways, then I usually try out LocalStack in those cases. So thank you for listening to this talk. I hope you learned something, and I'm happy to take some questions.